Note 2, the data graph below came from an experiment involving bronze and copper. The shading around the points indicates that due to potential errors in measurement, the data may not be exact. The line represented by the data points has been estimated. Write the equation of this line, which gives bronze as a function of copper. Note that the two scales are different. Okay, scales, if you can see here, every second dash here represents 5. So 5, 10, 15, 20. So that's 2.5, 7.5, 12.5, 17.5, and so on. Every dash here, every second dash represents 10, so every half dash is 5. So 0, 5, 10, 15, 20, 25, 30, and so on. They do use scales all the time on these problems. Be very careful. Also, the bottom's not always 0 and the side's not always 0, so be careful of that. For example, if this said 30, 40, 50, 60, 70, this would actually be 20 down here. So be careful, the bottom's not always 0, the furthest left is not always 0. So be cautious that you focus on that. They don't ever give you the number down here in the corner, but sometimes it isn't 0. So be careful of that. Second thing, we're trying to find the equation of the line. So let me highlight the line really quick so we can see exactly what we're trying to find the equation of. We're trying to find this equation here, this blue line. Look at the dots that are given, the data points they call them. Are all the data points sitting on the line? No. No. Do not pick the data points. Pick points on the line. Okay? And when you pick points on the line, my goal is for you guys to get close to the same answer as everybody else does. You're not going to get exactly the same answer because you're going to estimate something different than somebody else. My recommendation is 2 things when you're picking points on this line. Number 1, pick points that are not very close to each other. In other words, don't pick this point and this point. If you're off by just a little bit on both those points, you could get a line that looks like this, which is nowhere near the blue line, right? Which would be wrong. So don't pick points that are really close to each other. The second thing I'm going to say is estimate only one variable. Either estimate x or estimate y. Don't estimate both. So here's what I would do personally on this problem. I would pick this point right here, and I'd pick this point way up here. They're far away from each other. I'm dead on the y-axis value here, dead on the y-axis value there. So the y point, let me use different colors here. Let's use a green one for this dot. The green dot is something, comma, 0. And the red dot is something, comma, 50. I ensured the y value was 0 and 50, which is exactly 0, exactly 50. So all I have to do is estimate the x value. Okay, when I'm estimating the x value, you know, get close, but you don't have to be like 15 decimals close, just a couple decimal places. So looking at x, all right, this is 0, 2.55. All right, what do you guys think that is? Is it kind of halfway between 2.5 and 5? That would be 3.75. Ballpark it. Somebody might put 3.7, somebody might put 3.8. I can't argue with any of those numbers. I think it's 3.75. If you put 1.3, that's not a very good guess. All right? If you put 16.65, yeah, that's probably not very good. All right? But anywhere in the 3.7 to 3.8 range is probably a good guess. All right? That's all. This is estimating. You're going to use your eyes. You're going to kind of ballpark where it's at. Give me 1 or 2 decimal places with your guesses. Looking at this red one, and it's kind of got all globbed up in there. It's almost directly on this line, right? But it's just a smidge to the right of it, just a little tiny bit to the right of it. So I can see 15, that's 17.5. Maybe I go 17.55 or 17.6. I don't know. Let's go 17.6. Okay. There's no magic to those numbers. All right. I picked 2 values that were pretty close to the correct x values. I might be off by 0.1 or so. They're really far away from each other. So again, if I'm off by just a little tiny bit here, it's going to be just a little bit steeper slope or a little bit lower slope, but it's still pretty much the same line. So pick them way far away from each other and only estimate one coordinate. Once you've got both those points, this problem becomes just what the last problem was. Here's 2 points, find the equation line that passes those 2 points. Give me 2 decimal place approximations for the final solution. All right. My first job is to find slope. What are the y values here? 50 and 0, and then the x's are the other two numbers. And you guys want to start with the 0 or the 50? I don't care. 50, okay. So I'm starting at 50. So 50 minus 0 on top. And we're going to do 17.6 minus 3.75 on the bottom. That's how you find slope every time. Change in y over change in x. Make sure the y values, the second numbers go on top, the first numbers go on the bottom. And again, make sure the order of subtraction is the same. 0.2 minus 0.1, 0.2 minus 0.1. 50 minus 0 is equal to 50, obviously. 17.6 minus 3.75 is a little bit more challenging. That much more challenging. But since I've got a calculator available, I'm going to do it. 13.85. And we have 50 divided by 13.85, so 50 divided by 13.85. Make sure when you type in your calculator, I get some people calculating division backwards. This will be what's written on their paper, and they write 13.85 divided by 50 on their calculator. Top number divided by bottom number, that's how you enter it in your calculator correctly. We get 3.6101. Again, give me 4 decimal places in that approximation. Okay. Once you find m, you go y equals mx plus b. Which point do you want to use?
3.75.
Absolutely want to use that one. So I've got y is 0, x is 3.75, and slope is 3.6101. So I'm going to get 0 equals, oh, I'm supposed to be using red, aren't I? Tell you what, try and color code this stuff and use the wrong colors. 0 equals 3.6101 times 3.75 plus b. So it's a line. We're trying to find the equation line. The linear equation always has the structure y equals mx plus b. We have an x and a y and an m, so we substitute those three values in. We're left with this. 3.6101 times 3.75 is equal to 13.5379. So I get 0 equals 13.5379 plus b. So what does b equal? Negative 13.5379. So notice that we have a slope. We have a y-intercept, right? And our job is to find the equation line. Now, the last thing I want to do is write the equation properly. It says write the equation line which gives bronze as a function of copper. What variable do you think we're going to use for bronze?
B.
B. And how about copper?
C.
C. All right. So imagining using those two variables. Let's shrink my points down here and come up here. Okay. Which one of those is the y-coordinate? Bronze, right? And copper is the x-coordinate. And if we're imagining this y equals mx plus b structure we usually get, that's how we usually write equations of lines, right? But instead of using y, I want to use b. Instead of using x, I want to use c. I want to use variables that are meaningful to the experiment we're dealing with. I would put capital B for bronze equals 3.61 times capital C for copper minus 13.54. And I get my answers to 4 decimal places, but then I round my final solution to 2 decimal places. That will be an equation of that line, fits that data. Okay. Maybe if you use some different points, maybe you get 3.60 C minus 13.56. All right. If you pick points that are far away from each other and you're only estimating one variable, either x or y, you're going to get very, very close to everybody else's answer. If you're one of those that likes to check your answer in the back of the book, your answer will not match the back of the book answer. This should be pretty close. This could be a little bit further off, but they're both going to be pretty close. If you show me no work and give me the back of the book answer, you're wasting both of our time. Quit copying out of the back of the book. I can't stop you from doing it. I can promise you if you don't practice homework properly, when you see those problems on the test, you're going to be missing those problems on the test. There's no back of the book during a test. So practice the skills appropriately. Don't be lazy in homework. All right? But again, don't expect the back of the book answer to be showing up on your paper. It should be pretty close. All right? What you estimate for points might not be what the book estimated for